From 1852 until 1911, Hamilton's method of apportionment had been used to apportion congressional seats, and within that time several problems with this method had surfaced. The first flaw to arise occurred in 1880, known as the Alabama paradox. This occurs when an increase in the total number of seats to be apportioned causes a group to lose a seat. So this example says, a large company orders 144 new stand-up office desks. The company decides to apportion the desks according to the number of employees in each of 4 office locations in Seattle, Rapid City, St. Louis, and Boston. The table shows the number of employees according to each office location. Using Hamilton's method of apportionment, demonstrate that the Alabama paradox occurs when the shipment arrives. It contains 145 new stand-up desks. So we have this table here representing the 4 office locations. These are the subgroups. Here is our overriding total here. So the first thing we're going to do is we are going to determine the standard divisor using the 144 office desks here that they originally ordered. So using 144 seats here, 144 items, we'll go ahead and we'll divide this by 144. And this winds up being 18. Then, of course, we find the standard quota for each subgroup. So we'll divide this by the standard divisor. And this is approximately 53.222. Do the same for Rapid City. Divide this by the standard divisor. And its standard quota is 41.056. Do the same here. And this winds up being 34.333. And finally for Boston, its standard quota is 15.389. And 3 decimals will be plenty for these examples. We then use the quota rule and we round down according to Hamilton's method. We round down, so we round this down to 53. This goes down to 41. This goes to 34, and of course this goes to 15. Now if we add them up, 53 and 41, that's 94. 34 more, that's 128, and 15 more, that's 143. So we still have a desk left over. So according to Hamilton's method, that desk gets apportioned to the standard quota with the largest fractional component, and that would be this one here in Boston, 0.389. So the extra desk gets apportioned here. So there's 16 here. So according to Hamilton's method, ordering 144 new stand-up office desks, Seattle will get 53, Rapid City gets 41, St. Louis gets 34, and Boston gets 16. However, when the shipment arrives, there's 145 new stand-up desks. So now they have to apportion the 145. So if we go ahead and we do it again, here's the same table, except this time the number of seats has increased from 144 to 145. So we'll find our standard divisor again, but this time we use 145. 2,592 divided by 145 is approximately 17.876. And we go through the process again. We find the standard quota here, 958 divided by 17.876. That's 53.591. Do the same thing here. The standard quota for Rapid City, that's 739 divided by 17.876. That's 41.34. For St. Louis, divide by the standard divisor, we have 34.571. Again, remember that 3 decimals is plenty. And then for Boston, 277 divided by the standard divisor of 17.876. And this is 15.496. Again, using Hamilton's method, the standard quotas are rounded down. So this rounds down to 53, to 41, 34, and again, of course, 15. We add these up, 53 plus 41 plus 34 plus 15. Again, it comes out to be 143 new desks, so that leaves 2 more desks left over to apportion to allot to the offices. And again, using Hamilton's method, those go to the standard quotas with the largest fractional results. So here's 0.591 here. So Seattle will get an extra desk. That'll be 54. And then this one here, 0.571, that's St. Louis. They'll get an extra desk at 35. So what happens is we can see here that when there were 144 desks apportioned amongst the 4 locations, Boston got 16 and St. Louis got 34. But increasing the number of seats from 144 to 145, suddenly Boston loses a seat to St. Louis. You can see St. Louis now has 35 and Boston has 15. And that's the Alabama paradox.